Hello everyone, welcome back to Bite-Sized Practical Skills for Makers. My name is Zach and today we're going to be talking about soldering. In your experience as a maker, there has probably been a time where you've needed to solder something together. Most of us have a soldering iron and occasionally need to use it, but don't have full confidence that we're doing it right. In this video, I'm going to talk about the basics of soldering, what you need to get started, and then answer some of the most frequently asked questions. First, I'm going to talk about the equipment used for soldering. This little metal pointy thing is most often called a soldering iron. In this video, I'm going to be talking about soldering as it's related to electrical components. Soldering is also used to join copper pipes in plumbing, and that's a whole different topic that I'm not qualified to talk about. The first thing that I'm going to go over is some of the equipment that you're probably familiar with. This metal pointy thing that you use to solder is most often called a soldering iron. There are two main types of soldering irons. You've probably seen the type where it's just the iron and the cord coming off, which plugs directly into the wall. With the second type, instead of that cord going straight into the wall, it's plugged into a base station, and the base station will typically have a knob on it to control the temperature. This second type is sometimes called a soldering station because it has that base station. These two different types are used in different situations. A soldering iron with just the cord is very useful if you need to bring it to the location to solder something. For example, if you're working outside on a car or something like that and you need to solder something, it's a lot easier to bring just the simple soldering iron that has a cord versus a soldering station like this. On the other hand, if you're always working at a workbench like this and you want to be able to control the temperature of your soldering iron, then a soldering station is a much better choice. Here on the soldering iron, the very end is called the soldering tip, and that's the part that gets really hot. If you were to disassemble the iron like this, you'll see that these tips are actually removable because there are different sizes, and we'll go over that in a minute why you would want different sizes. But once you remove the tip, you'll find this white ceramic piece. This is the ceramic heater that heats up the tip and is able to melt the solder. Sometimes these ceramic heaters go bad and you have to replace them. When it comes to buying a soldering iron, a bad or cheap soldering iron will be more of a source of frustration than success. It's not worth cheaping out here. You want to get something of good quality that's going to set you up for success. When I started out, I bought one of the cheaper soldering irons and I never really could get it to work, and it was always frustrating. And then I found out that it was not me that was the problem, it was actually my iron. So that was a really frustrating lesson to learn. So since then, I've only bought good quality irons. As you go through the process of soldering something, at some point you're going to end up with residual solder on the tip of your iron. It's really important to keep your iron clean and maintained. There are two ways of cleaning the tip of your iron. Sometimes you'll see a wetted sponge, just like the sponge you use in your kitchen to clean your dishes. And then the other option is a brass sponge. Now this is one of those topics that seasoned hobbyists will have a flame war over in the comments section. Which one's better to use, the wetted sponge or the brass sponge? I used a wetted sponge for a really long time and eventually switched over to using a brass sponge. And the reason why is that when I used a wetted sponge, two things happened. I felt that the tip of the iron would cool down and it would not be very good long term for the tip to be thermally stressed like that, to be really hot and then be wiped on a wetted sponge where it would cool it down rapidly. I felt like that probably wouldn't maintain the tips very well. And the second reason is that moisture is a source of corrosion for the tip. The brass sponge solves this problem because there's no moisture involved at all. It's just a brass sponge where you dip your tip in there and all the little pieces of the brass sponge will clean off that tip much better. I've had a lot more success with maintaining my tips since I switched over to the brass sponge. If you think I'm wrong about this, the best thing you can do is tell me about it in the comments. One of my favorite things to do is to read all of the reasons why I'm wrong in my comment section. Earlier you saw me disassemble the soldering iron, and that allows you to remove the tip. The reason you can remove these tips is because there are different sizes that you can put on your soldering iron. Smaller tips are obviously for smaller work and they don't conduct as much heat from the heating element. Larger tips can absorb a lot more of that heat and transfer it to the part that you're trying to heat up. So if you're having a problem with heating up a component and that your solder is not melting, it's probably because you're using a tip that is too small. You need to swap out your tip for one that's bigger and is going to transfer that heat a lot more. Now let's talk about the actual solder. The most common type of solder is a mix between tin and lead. It's usually about 60% tin and 40% lead. Solder will typically come in a 1-pound spool like this, which can last you a really long time. I do a ton of soldering and I've had this for probably 5 or 6 years and I've barely made a dent in it. The other common type of solder is a lead-free lead-free solder. Using lead-free solder is a lot more common in the professional industry where they need to comply with environmental standards. Keep in mind though that lead-free solder is a bit harder to work with and it doesn't behave the same way as leaded solder. If you're just starting out with soldering and you don't need to comply with these environmental standards, I would recommend using a tin lead alloy like this one. When you go to buy this stuff, make sure you're getting solder that's intended for electrical components. You're going to have a really hard time if you're trying to use plumbing solder on electrical components. Most of the time I'll keep the solder on this spool holder so that it's easy to dispense. The last thing I want to talk about is a really important piece of safety equipment. This is a fume extractor. When you solder, there's a lot of fumes that are released that are not good for you to breathe in, so it's really important to have really good ventilation in addition to a fume extractor like this. This fume extractor has a charcoal activated filter just like this one, and it removes all of the harmful particles out of the air so that they don't get into your lungs. It is a common misconception that the fumes that you see when you're soldering are lead fumes. That's not the case. It's actually the flux that's inside the solder that causes most of those fumes. We're going to talk about flux in a minute. Make sure you're safe while you're soldering and use a fume extractor. I want to move into talking about your workspace setup and some of the techniques that I've learned along the way. When it comes to soldering, you want to make sure that you have plenty of space to do your work. You don't want to be in a cramped space on the edge of a really cluttered table and having things go wrong. Make sure you have a clean workspace that's not cluttered with plenty of room for your arms and whatever it is that you're working on. Now I'm right-handed, so obviously I'm going to want the soldering iron on my right-hand side, and I usually push the soldering iron as well as the base station all the way to the back edge of my table. Now if you're left-handed, obviously you would just mirror this setup. Now since the iron is going to be held in my right hand, I'm going to be using my left hand to hold the solder, so I'll put that over here. Now you can solder on pretty much any surface, but obviously it's hot, so what I like to do is get a ceramic tile from your home improvement store and just kind of use that as a base. A ceramic tile like this is going to protect whatever surface is underneath it from all of the heat that you're generating. Now keep in mind, this isn't going to protect your circuit boards from electrostatic discharge. For that, you're going to want to use an ESD mat like the one I have here, as well as a wrist strap. Now that you've got your workspace set up, it's time to turn on your soldering iron. One of the questions that I was asked in preparing for this video is what temperature you should set your iron to. The answer to that question depends on what kind of solder you're using. Anytime you buy solder, it'll tell you on the package or in the data sheet the right temperature you need to use for that specific solder. In my experience, that's usually 350 degrees Celsius or 662 degrees Fahrenheit. Once you turn on your soldering iron, it will typically take 1 to 2 minutes to get it up to temperature. Now that the iron is hot, it's time to start soldering. Before you start soldering, you want to make sure that the tip has a thin layer of solder on it. This is called tinning the tip. When you have a brand new tip, sometimes it takes a few applications of solder in order to build up that small layer of solder on there. So you want to kind of rotate your iron while applying solder. When you tin the tip of your iron, you ensure that all of the oxidation is removed from the tip. You can remove the glob of solder by cleaning the tip in your sponge. So you should have a nice, shiny, silvery tip. If you see any black or oxidation, you're not going to get a good solder joint. I will usually tin the tip every time I pick up or put back the iron. It might sound counterintuitive, but sometimes I will leave a glob of solder on the end of the tip, put it back in its holder, and turn the iron off. This creates sort of a protective barrier around that tip so that it doesn't oxidize. You can also purchase a tin of tip tinner. That's hard to say, that's a tongue twister. You can also purchase something that's called tip tinner. This is basically like solder, but it's in a powder format. When you dip the tip of your iron in there, it basically tins it for you, and you can do that instead of using regular solder. Using this tip tinner is a great way to maintain your soldering iron and ensure that it lasts a long time. Now I'm going to go over some basic techniques and show you how to solder components on a circuit board. When most people try to solder, they will try applying solder to the end of their tip and then try to paint the solder onto the joint. This is the wrong approach entirely. The reason is because solder will flow into the hottest part of the joint. If your tip is the hottest part, that's where the solder is going to stick to. It's not going to get into the joint properly. So what you need to do is use the tip of your iron to heat up the surface that you want the solder to adhere to. Once you've heated up your joint and apply the solder will flow into that joint and rather than clinging onto the tip of your iron. This definitely takes some practice, but it's worth learning to do the right way. I have a little prototype board here along with some components, and I'm going to go ahead and solder these components to the prototype board. There are several options to holding your workpiece as you solder components to it. The first one is called helping hands. I'm sure you've seen something like this. It's basically a metal rod with some alligator clips at the end that help hold on to things as you solder to them. This works great in a lot of situations, especially when you're soldering wires. If you're soldering a rectangular board like this, my favorite tool to use is something called a pan of vise. It's basically a little vise that is designed to hold circuit boards. You basically can slide in the circuit board like this and clamp down on it. And one of the cool features of this particular vise is that you can loosen it and flip it over so you can work on both sides of the board. This tool is particularly useful when you're working with through-hole components like a resistor like this, because you can slide it in the top and then loosen it, flip it over, and then apply your solder to the joints down below. The big problem with this setup is that it elevates your workpiece by like 4 or 5 inches, so you're kind of hovering above it, and it's not a very comfortable way to solder. So there's a third method that I use to hold workpieces, and that is poster putty. So I'll take a big glob of it like this, and I'll work it with my hands until it's a little bit soft, and then I'll stick it down and then press my workpiece into that. And that kind of holds it in there in place. This poster putty will wear out after a lot of uses, so you'll need to replace it. But this is one of the methods that I've discovered over the years of soldering. Most components won't be able to stay inserted because now gravity's trying to pull them out. So I'll either hold it with one finger or I'll bend the leads over so that it stays in place while I solder. So like I said earlier, I'm gonna tin my tip just a little bit here. Make sure that there's no oxidation, and then clean it off in the sponge. And then I'm gonna apply the soldering iron tip to the joint and just kind of warm it up for a couple of seconds. I'll kind of put a little bit of solder on there, and you can kind of see that it flows into the joint. So I'll keep adding a little bit at a time, holding my soldering iron there the whole time. And what I'm looking for is a nice clean little rounded fillet on that solder joint. So once I'm happy with it, I can release my soldering iron and then let it cool down. You wanna heat up the joint, get it nice and hot, and then let the solder flow in there. It's going to wick into the hottest parts. It's going to use kind of surface tension of the liquid and seep into the joint really nice. Another kind of rookie mistake is accidentally taking your iron away before the solder's cool. So I'll go ahead and do that, and then I take away my iron, and then guess what? Now my spool of solder is stuck to the joint because I took the tip away before I took the solder away. So first take away the solder, let it seep in there, and then take the tip away. I apologize that this is a little bit hard to see. I'm trying to get a good camera angle here, but as you can see, these joints all have a nice, clean, rounded fillet at the base of the joint. Let me give you an example of a joint that would have too much solder on it. So that first one, I'm gonna go back, and I'm gonna keep applying more and more solder, all the while leaving my soldering iron on there. And I'm gonna get a bunch of solder on there. Now it kind of looks like a little ball at the bottom. It's not like a fillet, like a Hershey Kiss. It's too fat at the bottom. And the problem with that is that sometimes you get solder bridges, which looks like that. That's where two joints that are not supposed to be connected have solder between them, and that's not good because that can short out circuits. It can totally ruin your day if you get a solder bridge like that. When you're working with solder, you're actually working with a liquid, so there's a lot of liquid properties like surface tension that come into play. So it's like two droplets of water want to coalesce together. It's the same when you get too much solder between 2 points like this. They want to coalesce together and make a big solder bridge, which is not good. So make sure that you don't put too much solder on your joints. Now that this is kind of tacked into place, if you will, I don't need this lead bending over like that to hold this in place. So I'm actually going to bend this back up so that it's sticking straight up. And I'm going to go ahead and finish off that row of pins so that it all has nice solder joints. So again, I'm going to put the tip on there, let the joint heat up for a little bit, apply a little bit of solder, apply a little bit of solder, leave it there, and then take your tip away. If you have a soldering iron, I'd recommend practicing these techniques because you'll get better and better and you'll have a much more enjoyable experience. What happens if you want to solder the ends of two wires together? There's a couple of different techniques. If you really want to go crazy, you can read the paper that NASA put out a long time ago on the proper way to join two wires together in a solder joint. I haven't read that paper myself because I found that the way I do it works just fine, and I'm not trying to send anything to the moon. So I'm going to be okay with the way I do it. Like I said earlier, I will typically use the helping hands when I'm joining wires together. So I'll put one end facing me like this, and I'll clamp onto that. And in fact, if it's frayed a little bit, I'll even twist it just to kind of clean up that end so that it's nice and twisted. And then I'm going to tin the end of this wire. And I'm actually going to leave a little bit of extra solder on this. I'm going to leave a blob, even though normally I wouldn't want to, but I need some extra solder in that joint so that it binds the two together. So I've got the red wire tinned and it has a little extra blob of solder on there. I've tinned the blue wire, so I'm just gonna kind of bring it together, put the iron on there, let them flow together, cool down. Make sure that it's all the way cool before you let go. Make sure that this kind of solder joint is never used in a situation where the wires are in motion or they're going to be bent back and forth repeatedly, because that will totally break over time. So this should just be used in static conditions. The other technique is to leave the ends of the wires kind of frayed a little bit, and you can even spread them out a little bit, and then push the ends together so that they kind of interlock, all the stranded wire kind of interlock like fingers like that. And then you apply the solder joint, and that actually adds a little bit of extra strength. If you want to insulate this point from other electrical connections, you can use heat shrink. So you can just slide a little length of heat shrink on there, cover the joint, and then apply heat either from a hot air gun, or actually if you're in a pinch, you can even use your soldering iron like this and just kind of slowly dab it on there and shrink that heat shrink down. I tend to just use a heat gun because I've got one handy, but in a pinch this works just fine. And now that's insulated from other parts so it won't short out on anything. If you really want to ensure that there's no water that gets into a joint like this, you can use adhesive lined heat shrink. So it actually has some glue inside there, and when you heat shrink it down, it'll squeeze out and really create a watertight joint. If you're going to be doing a lot of soldering, especially on small components, it's a good idea to use magnification. This gives your eyes a little extra help and will prevent fatigue over a long period of time. Some of the little helping hand tools that I've purchased in the past will also include a little magnifying glass. I personally have not found those useful. They're very hard to get right and to get the focal length right so that it's useful. So I would not recommend buying one of the helping hands that has a magnifying glass. Instead, you might look for one of those visors that has magnifying glasses built into it. I personally do enough of this that I invested in a microscope. It's on an articulating arm and it can move up and down. This has been really awesome and super helpful. It was really expensive, so this is definitely not for everybody, but if you're into this professionally, I would recommend investing in something like this. One of the questions that I was asked in preparing for this video is to talk about flux. Flux is a substance that helps clean the solder joints as it's being applied. More often than not, the flux is actually included in the solder. It's called flux core solder. As you apply flux core solder to the joint, that flux mixes in with the solder and make sure that there's no oxidation or impurities in the solder as it cools down. If you keep working on a solder joint and keep applying the soldering iron, after several times you're going to start to see that the joint isn't as good of a quality. It's not shiny, it's starting to get dull, and you can see impurities and oxidation. So at that point you can actually apply more flux to the solder joint to kind of clean it up. Solder flux will typically come in a pen format like this. It just has like a little felt tip and you'll dab it on. I used this for several years and actually decided I don't really like this kind. Recently I switched to kind of a flux gel that comes in a little syringe like this, and I put a little lure lock tip on the end and I can just apply a little bit on there and then heat up the joint with my soldering iron, and that allows the flux to kind of clean up the joint. It cleans up all the impurities, and I found that I like this style of flux a lot better. A cold solder joint is when the solder doesn't make a good electrical connection and it's unreliable and it can become a problem in the future. For example, a cold solder joint might be when the solder just kind of globs up top in a ball and doesn't really seep down and make that nice fillet. The easiest way to fix a cold solder joint is just to apply the soldering iron again and heat up that joint, allowing the solder to melt and seep into place. You might want to add a little extra flux in that new solder joint just to make sure that it doesn't have any impurities. What happens if you are not happy with your solder joint or you need to remove a component from a board? This is sometimes called reworking a solder joint. There are several options for removing solder from a joint. The most common of which is called solder wick or solder braid. This is just a woven copper braid of wire. Apply your iron on top of it and it'll heat up both the wick and the joint, and this will actually kind of wick up that extra solder and store it in here, kind of like a candle wick. Another tool that I use occasionally is something called a solder pump. It looks like this. So you just kind of push down the plunger here and then you heat up the joint really well until the solder's melted, and then you stick this over the top. And now there's going to be a vacuum in here when I release it, so it's actually just going to suck up the solder. The last tool that I use to do soldering rework is just a hot air gun or a rework gun. And this one is attached to my soldering station. I can control the temperature, so I just set the temperature to something above the melting point of the solder. So in this case, I usually use something about 375 degrees Celsius. And I apply heat to the solder joint, and I can see when it kind of becomes liquid and melts, and that's when I can remove parts. As you practice getting better at soldering, you might come across a time when your solder joint is just not melting properly and you're asking, well, why isn't my solder melting? So there's a few things that you can check in this situation. The first thing I would check is to make sure that your temperature is set to the right melting point. The solder is not going to melt if your iron is not hot enough. Next, you want to make sure that the tip of your soldering iron is tinned and that it's clean of debris and any impurities. This is going to help transfer the heat to the solder joint and help it melt a lot better. Next, I would check to make sure that the tip that you're using is big enough to transfer enough heat into the joint. If you have a really big component that's connected to the ground plane of the PCB, for example, you're going to want to use a bigger tip on your soldering iron so that it will transfer more heat into that solder joint to make sure that it melts properly. And finally, if you've checked all of these things and it's still not melting, you can crank up the heat a little bit on your soldering iron. I definitely wouldn't get carried away with this and crank it all the way up all the time. This is something you want to use very sparingly. I always keep my iron set just above the melting temperature of the solder. You shouldn't rely on having to crank up the heat on your soldering iron a lot. This is going to cause long-term damage to your heating element, your tips, so just avoid that if you can. If you're interested in getting some of the same equipment that you've seen in this video, I'm going to have affiliate links down in the description so you can go check those out. If you have questions about soldering that I didn't cover in this video, I would love to hear about them down in the comments. Also, if you're interested in learning about soldering surface mount components, let me know down in the comments. I can make a supplemental video to this just dealing with surface mount components because there's a whole new set of different techniques and tips that I've learned over the years. Finally, if you have a suggestion for a practical skills video that you'd like to see me make, let me know. I'd love to hear your suggestions for different topic ideas of videos that I can make. If you're new to Bite Size, you may not know that I make project videos in addition to these practical skills videos. If you're not subscribed to Bite Size, be sure to do that so you can keep up to date with the projects that I'm working on. You should also consider becoming a Bite Size supporting member through Patreon or YouTube memberships. When you become a channel member, you get access to cool things like behind the scenes content, early video releases, monthly hangouts, and I have a Discord server set up where we can talk about different things that we're working on. Not only is this a great way for you to support the channel, this is a great way for me to connect to you guys on a more personal level. Thanks for watching this video, and I look forward to seeing you next time. Before I go, I want to tell you about the sponsor of this video, which is Altium. Altium makes a PCB design software called Altium Designer. If you've ever done any sort of electrical design, you're going to want to check out Altium Designer. In my career as an electrical engineer, I've used a lot of different software, and let's be honest, most of it is crap. That is not the case with Altium Designer. It is beautifully designed, it's modern, and they're continually updating it to have the latest features. What's cool about Altium Designer is that it's an all-in-one platform. Some of the other software that I've used, you have to use different programs to do your schematic capture, and then your board layout, and then your component selection and your netlist, and it's a huge mess. That's not the case with Altium Designer. It's all built into one package. Another cool thing about Altium is that it has cloud features. It's got something called Altium 365, which is a cloud workspace that allows you to collaborate with other people and do version control. If you want to get a better idea of what you can make with Altium Designer, go follow them on Instagram, and there's lots of different examples of what people have made using their software. If you're ready to take your PCB design to the next level, go check out Altium Designer, and you can do that by clicking on the link in the description, and when you sign up for a subscription, you'll get a 30% discount. Altium is an awesome company. They believe in what I do here on this channel, and they make these videos possible, so go check them out. I really appreciate you supporting the sponsors, and I appreciate Altium for sponsoring this video.